Hi guys, today I will show you how does a TPM 2.3 analog processing look like in measurement. So that day Andy have shared you the overview of this whole power amplifier, and he let you to listen to different kind of settings in the analog processing. So let's dive into it and have a look how does the processing looks like in the measurement software Smart. Let's go.
Okay, now we are in the software, smart measurement software, and I shall share you the frequency of the full range speaker and the subwoofer. But as I mentioned just now, we are measuring in a non-ideal area. It's not in the anoic chamber, so it's just at an ordinary room with a minimal acoustic treatment. Okay, and this is our IVA RX12 Mark II full range speaker. So this is the original frequency response. And if I apply a 90 Hertz cut, and you can see, yes, in red color, there's a definitely 90 Hertz cut here. So 90 Hertz is around this area. And then we proceed with a 125 Hertz cut. 125 is around here. And next we have a 150 Hertz low cut. So 150 is around here. As you can see from my screen, you can see different kind of crossover low cut for my full range speakers. Then I apply the same crossover point, but this time to a subwoofer. So now I'm doing a high cut or low pass filter. What I'm using now is an IVA SUB118B. It's an 18-inch subwoofer from IVA. So this is the flat frequencies from the subwoofers, and you can see it's going up all the way to 1.1712 kilohertz. So this is the full range from the subwoofers. So if you use the 90 hertz cut, and you can see the graph is definitely being cut, and then 125 hertz, so it's around here, 125, and then we have 150 hertz. So we can see 125 and 150 is not much different. But take note also, because this is an analog, we are tweaking from a very maybe not so sensitive knob, so it's not so accurate, but you get the results. So now we have cross point for both the subs and the full range. How about if we combine both? So maybe, for example, channel 1 is a full range, channel 2 is a subwoofer. Whether these two speakers will align properly. Because if there's a phase shift, and then the crossover point will not have a good summarized frequency. So let's have a look at 90 Hz. And I shall open back the 90 Hz for the RX15 and the 90 Hz for the subwoofer. So you can see from the screen. And now, what is a resultant combination of these two speakers? And here you can see around the crossover point, we have a good summation of the frequencies, and very good. There's no cancellation between the full range and the subwoofers. So far so good. And then we have a look on the 125 Hz, 125 at RX12, 125 at subwoofer, and 125 for the summation of both speakers. So pretty good so far. We have a good summation around the crossover area. So how about 150 Hz? So this is a 150 for the full range, 150 for the subwoofer, and 150 for both. Okay, around the crossing area is pretty nice. We have a summation of both speakers, but we have a bump around 120 Hz. So this could be because just now I mentioned the knob could be not so accurate, and this could be the causes that create this bump. Of course, some of them doesn't like the bump, because they want a flatter sound, but some they prefer this because it bump up the bass at 117 hertz. So it depends on you. But I believe if we can do a fine tuning, if we want to get a flatter frequencies, we should able to do so. But in this experiment, I did not go further to achieve that. And remember, there's an additional features called the signal processing. So actually, this is a bass processing to apply a equalizer on the bass. So I did an experiment to boost a bass for the crossing at 90 hertz. So let's have a look at the 90 hertz and the resultant. So I just turn on the bass processing and see what is the result. And you can see there's a bump here around 100 hertz. So plus minus all the way down to about 56 hertz up to around 300 hertz. So we have about a 6 dB bump centered at about 105 hertz. So frequency equalizer up. And this one you can listen clearly when you are live in front of the speakers. And now if you wonder, we did so many crossing 90, 125 and 150 hertz for the full range speakers. So this is in an analog domain. How does it look like in the digital, or what kind of settings in digital can achieve the similar results? So what you see now is a 90 hertz low cut for my full range speakers. And if I go to the digital domain, so I need this to achieve quite similar result. This is the BUT 24 filters at 60.1 hertz. I can achieve quite similar results. So there's a slightly amplitude difference, but we roughly get the similar graph. This is the 125 hertz low cut for the full range speakers. And in order to achieve that, I need to apply a Butterworth 24 at 109 hertz to achieve a similar result to my 125 low cut at my full range. We have 150 hertz low cut for my full range. And to get that, I need a Bessel 24 at 130 hertz to get similar result. So now you have it, the results from my measurement. Hope that this will help you in maybe determining whether this amplifier TPM 2.3 is good for your installation and for your usage. And although this analog processor is a simple one, but I believe it's very good enough. It's good enough for your daily usage. So it can save you some of the monies in the project and in your wallet. So hope this helps you, and I guess I will be seeing you again in the next video. And bye bye.